point on. And I'm going to go ahead and kill my camera as well, because it allows the video to go a little bit better if I shut my camera off. So let me go ahead and kill my camera. And then we'll go ahead and get started here. And Randy, I'll let you kind of be the monitor as well to make sure that the PowerPoint's going well and all that kind of stuff.
Yep, you bet.
And so we should be up to that first screen on the PowerPoint.
Yep.
And so you should be able to see HMH17 heat pump overview, and then the two products on front. Is that correct?
Got it.
Well, fellas, welcome this afternoon to our first training session of 2022. I appreciate you guys joining us today. Please, by all means, if you have questions, just have those questions, unmute your mic and ask those questions, or hit it in the chat box. Randy's going to be our monitor on the chat box, so if any questions come up, we'll have the opportunity to answer those questions for you as we do our training today on our HMH17 SEER horizontal discharge heat pump product. Now, fellas, this is a new product for us, but so far we've had some really good luck with it. Very few issues have cropped up. The big ones have been application more than anything else, as far as, how do we hook it up? What do we do? What's that relay package for, and so on. So we're going to cover all that stuff today in our training session specific to the HMH7 SEER heat pump product. So a couple things we'd like to talk about first and foremost as we start to kind of get going here is we're going to please remember that the unit service fittings are actually 5/16. And so in order for the contractor to utilize their service gauges in a normal fashion, what they're going to have to do, they're going to have to make sure and have this field adapter, or this flare adapter more specifically. And what it does is it takes that 5/16 fitting from the unit to the 1/4-inch fitting on their service hoses. Now, this is a very common adapter. You'll find these a lot of times on mini splits. And even though these are not mini split products, they still have that same type of fitting. And so these adapters, they're available from several sources, Robin Air and Yellow Jacket and so forth. They all make them. But again, it's a 5/16 female to a 1/4-inch male flare fitting adapter, so they can hook their service hoses up to the unit. Another thing that we kind of get questions about are, what is the unit capable of as far as minimum, maximum temperatures concerning outdoor as well as indoor air temperature. So this is right out of the install information. This can be found if you go to your Navigator website. You'll be able to pull down the install information and actually see this. But as you can see, the minimum cooling on the outdoor is going to be 35 degrees. And minimum heating is going to be -5 degrees right out of the box. Indoor coil 57 wet bulb and 50 degree on the heat for cooling and for heating. And then the maximum operating temperatures are going to be dry bulb temperature outside, maximum 122 degrees for cooling, 75 degree for heating, maximum outdoor temperature. And then on the indoor coil, 72 degree wet bulb and then 80 degree dry bulb in the heating mode of operation will be considered normal operating parameters. And again, all this information that I've just spoke about, and there's the little tag there that you can see, the little text field that's available. You can read all about that in the install information. Any questions or comments so far before we continue?
Joel, I have one here.
Sure.
At -5 in heating, does the unit continue to try to run, or does it lock out at -5?
That's a good question. I've actually had field reports of it doing both. So basically, it'll throw a little code, and then it will go through a lockout procedure. But if you think about it, that -5 minimum temperature for heating, at that point, the heat pump has reached a point, Randy, where, and that's a good question, it reaches a point where the amount of heat that it's generating is not going to be sufficient to heat the space, and that's why they do that.
Okay.
Good question. Okay.
Does that automatically come back on then when it gets back to -5 or -4?
Yes, it will. Yeah, all the field reports I've had is that's basically a point where the outdoor unit senses that it's not going to be able to make heat, but once the temperature rises above that, it resumes normal operation. That is correct. Good question. Good question. Okay, so fellas, at this time we're going to be discussing the low voltage wiring and setup of the heat pump with an AE air handler. And the AE air handler just features a standard ECM motor. Now, depending on what part of the country you're in, you may be using air handlers, you might be using furnaces, but we're going to cover all those products in our overview this afternoon. We're going to talk about the low voltage wiring with an AE air handler and a real simplified block wiring diagram that we'll display on the screen here for you. Now, please remember the AE air handler has no hard physical screw terminals, but it's equipped instead with pigtail connections. So just remember there's going to be wire connections on the AE air handler. We're also going to talk about the wiring of the accessory single pole double throw relay in the indoor unit and how it's used for airflow reduction. So I want you to kind of wrap your heads around this. So what happens is when the outdoor unit makes some intelligent decisions on when it needs reduced airflow at reduced capacity, it'll go ahead and send a signal to a relay inside to reduce the airflow. So we're going to talk about how that works. Now we're going to recommend kit number HMH7AK001. And we're going to recommend this because it's very, very convenient and it has all the supplied parts for the unit. So in other words, that kit's going to contain the relay. It'll contain some little wiring harness or some little wires field supplied wires, as well as a bi-flow filter dryer. Now, this is the only product we have in our inventory that does not have a factory installed filter dryer, but we do provide one in this HMH7A001 kit, okay, along with the relay and so on. So we recommend that you buy the kit for convenience. Now, the obvious question is going to come up. A contractor may say, well, you know what? I've got my own bi-flow filter dryers, and I don't mind making up some field wiring of my own, and I've got a single pole double throw relay on my truck with a 24-volt coil. Can I use that instead? Well, of course you could. A single pole double throw relay with a 24-volt coil and a bi-flow filter dryer and field installed field wiring would be perfectly acceptable. But for convenience, we recommend this kit because it comes with all that stuff in it already. Now, it should be noted that the HMH7AK002 relay kit may be used. This is kind of the universal kit because it can be used on any of the product as far as AE air handlers, variable speed air handlers, furnaces, etc. So the 002 kit is actually kind of a universal kit. However, the RV relay on the 002 kit will not be needed for this particular application. So for the AE air handler, simple application, the 001 kit is just the simple relay kit. The 002 kit has all the same stuff in it, except it has 2 relays instead of 1 relay. And that's kind of an easy way to remember it. The 001 kit has 1 relay. The 002 kit has 2 relays. And the 002 kit, you have to use that on the variable speed products, but it's kind of universal in the fact that if you do want to use it on an AE air handler, in our example, you will not use the RV relay. So in other words, you'll just be using one of the relays on that 002 kit if needed. Now, it should be noted also that a heat pump thermostat has to be used with the HMH7, and that thermostat has to have a BO selection for reversing valve operation. And we'll get a little bit more into that when we start doing our low voltage wiring review. So again, the heat pump thermostat has to have the BO selection for reversing valve operation. Okay. So let's go ahead and talk a little bit about just a standard 24-volt heat pump thermostat with the AE air handler. And please remember the AE air handler does have pigtail connections, even though we're showing like W1, W2 on the little block diagram here. Just please remember those connections are actually pigtails. They're not hard screw terminals like you'd find on a furnace. So here we go. So starting at the thermostat on the left-hand side, we're going to take a wire directly from B straight outside to the heat pump outside. Now what this is B terminal is for reversing valve operation in the heating mode of operation. So the thermostat has to be equipped with the capability of selecting B or O for reversing valve. Now it should be noted, please, this is the only product we have in the inventory that we energize the reversing valve on heating. All of our other Champion heat pump products, both commercial and residential, we energize O terminal for cooling. So this is exactly opposite. Now it's not bad, it's just different. So please remember, on the HMH7 heat pump product, we're going to energize that B terminal from the B terminal on the thermostat for heating mode of operation on the heat pump. So we energize B for heating. W2 is our second stage auxiliary heat, and we're just going to be featuring a 2-stage heat strip today. This could be like a 10 kW, 15 kW, etc. And if you have a 2-stage heat strip in here, W2 will be your second stage auxiliary heat. W1 is your first stage auxiliary heat, or your first stage heat strip. And you'll notice that W1 goes from the thermostat to the indoor unit and then also outside. Now, it should be noted that during defrost operation, the outdoor unit will energize the W terminal outside to bring on that first stage of heat strip during defrost. That's why we have to have that W wire going all the way outside as well, so we can have the heat strip coming on, one stage of the heat strip coming on when we go into defrost. Y terminal on the heat pump thermostat goes straight outside, and this is going to be our compressor call. Now, it should be noted, it's real important on the AE air handler, you're going to have a factory installed yellow wire on the ECM motor. And what you're going to do, you're going to remove that wire. So from the factory, you may have a Y or a yellow wire on the air handler itself, on the motor itself. And what you're going to do, you're going to remove that off the actual ECM motor, because we're going to do something else with it after a while. So Y from the thermostat goes outside to Y on the outdoor unit. C terminal goes all the way through. That's 24-volt common, and that would pretty well be expected. C from the thermostat to the common wire. That's typically a blue wire that goes outside to C terminal outside. R terminal is our 24-volt hot. Now, please note something. The R terminal connection, or the hot wire connection from the air handler, goes to the heat pump thermostat. It does not go outside. Let me say that one more time. The R terminal does not go outside and hook up to the control board outside. We don't have to have it on the HMH7, so it's a little bit different from our other Champion product. Again, it's different. It's not bad. It's just different. We don't have 24-volt R terminal going outside. So please remember that 24-volt R terminal from the thermostat to the indoor unit only. G terminal is our fan call, and that's pretty standard in the industry. You're going to have a G wire or green wire typically from the heat pump thermostat over to the G terminal, or the green wire on the air handler inside. Any questions or comments on the basic low voltage wiring so far before we start jumping into the relay and how we're going to hook up that standard ECM motor on an ECM, or that standard ECM motor on an AE air handler? Any questions or comments so far?
Yep, we're good here, Joel.
Everybody good? All right, fellas, I'll tell you what, let's talk about hooking up that 001 relay. So this little 001 relay, I'm just showing it as just a single pole double throw relay in the air handler. We're going to mount it inside the air handler. And I think the actual kit itself, fellas, actually comes, the relay is actually mounted on a little board. But it doesn't matter. It's just a single pole double throw relay. And so let's talk about how we're going to hook that up. So what we're going to do, one side of the relay coil, that's a 24-volt coil, one side of that relay coil, we're showing B terminal, is going to go up, and it's going to hook to a wire on the outdoor unit called S1. That S1 is an output, a 24-volt output from the outdoor unit to B terminal, or one side of the relay coil, and that's going to energize that coil. When we have reduced airflow, we're going to energize that coil, and we'll show you how that works here in a little bit. The other side of that coil of the relay, we're using A terminal in this example. The other side of that coil goes to 24-volt common. So here's the idea: when the outdoor unit sends that 24-volt signal on S1, it's going to change or click that relay or energize that relay. Common terminal, the common terminal of the switching contacts on the relay, are going to tie into that yellow wire going outside to the outdoor unit, from the thermostat to the outdoor unit. So what we're going to be doing anytime we have a Y call on the thermostat, it's going to energize, or it's going to have available to it power 24 volts to the common switching terminals on the relay. You'll also notice on the ECM motor, remember we took that that yellow wire off. We're going to select a high-speed tap on the ECM motor, and we're going to hook it up to W1. So here's the idea. So if I have an auxiliary heat call, or during defrost, if I get a W call from the outdoor unit, anytime we have a W1 auxiliary heat call, it's going to energize the high-speed tap on the ECM motor and call for high-speed operation. Now, the reason we do that is we want to make sure we have adequate airflow, because the heat pump's going to be running, it's going to be in defrost, or we're having an auxiliary heat call, and you're going to have a heat strip running at the same time. So we want to make sure we have high airflow on that. So anytime we have a W call, a first stage W1 call is going to energize that motor, or the ECM motor is going to command it to high-speed airflow. This is very typical. And so that's you know, more often than not, this is exactly how we see that. Now, the contractor, if he did some airflow measurements and he needed to adjust that, he's perfectly capable of doing that. But I'm just mentioning this is typically how it's hooked up, where you have a defrost call W, or a W1 input from the thermostat. We're going to energize that ECM motor on high speed. The normally closed contact on the relay, on that little single pole double throw relay, the normally closed contact, there's going to be a wire that's going to be hooked up from normally closed over to the ECM motor to provide 100% cooling airflow. So now the contractor, when he sets this unit up, he's going to have to make sure and measure his airflow, and he's going to set up that 100% airflow based on the tonnage of the outdoor unit. To give an example, let's say I have a 3-ton unit outside. That 100% airflow setting is going to need to be 1200 CFM on a 3-ton unit. We always want to make sure our cooling airflow at 100% is 400 CFM per ton of cooling. So if we have a 2-ton unit outside, it'll be 800 CFM. If it's a 3-ton unit outside, it'll be 1200 CFM, and so on. So the normally closed contact on the relay is going to energize the ECM motor on 100% cooling airflow speed tap. Any questions or comments on that? Everybody good?
No, we're good, Joel.
Okay, excellent. So the next contact on the relay you'll see is a normally open contact. A normally open contact, we're going to go over and we're going to select a speed tap on the ECM motor to provide 60 to 65% airflow. So that's your airflow reduction. So when we call for reduced airflow, because remember the HMH7 heat pump is a five-stage modulating heat pump. And so what it does, it actually modulates, and when it hits a certain point of modulation, it's going to generate an S1 call. And what it will do, it'll switch that relay and call for reduced airflow. So when we are in our lower airflow requirements, 35, 40, 45, 50%, whatever airflow, we're going to reduce that airflow. So the ECM motor needs to be blowing on reduced airflow between 60 and 65% of our cooling airflow. So as we hook this up, we see it's designed to let the outdoor unit make intelligent decisions based on its point of modulation and its point of capacity to reduce the airflow on the inside unit with that little switching relay. So as we take a look at that, again, there's our block diagram, how we're going to hook it up. Now watch this. Let me go ahead and do an animation real quick. Let me watch the screen closely, everyone. When I get an S1 output from the outdoor unit, we energize S1. What it does, it energizes the relay. It switches from a normally closed to normally open set of contacts. And you'll notice that S1 input from the outdoor unit actually switches relay and commands reduced airflow. So the outdoor unit's making intelligent decisions on when it wants reduced airflow on the indoor unit based on the capacity of the outdoor unit, where it happens to be at any point of capacity. Any questions or comments how we're utilizing that outdoor unit to make intelligent decisions to control our indoor airflow for reduced capacity?
So, so do you have to get this kit for every one of these heat pumps we sell?
Absolutely. Thank you. That's an excellent question. And so the reduced airflow capacity on the indoor unit is going to be switched by that little relay kit. Now, for convenience, we build these kits up for you as far as a bi-flow filter dryer and some little wiring, some pre-wired pigtails, and the little single pole double throw relay, and so on. But the obvious question again comes up: well, if a contractor has his own bi-flow filter dryer on his truck, can he put that on the liquid line? Sure. And if he has just some little generic switching relays, could he use those? Well, absolutely. But he's going to have to make some field installed wiring. So it isn't like you have to buy our kit, but we provide it for convenience. Good question.
Why don't they just automatically put these in the units?
You don't think what?
Why don't they automatically just give you this in the packaging with the outdoor unit?
That's an excellent question. In my view, that would be a something to definitely consider. And Randy, you might want to write that down or put that on the parking lot, and bring that to the attention of our leadership. Maybe during a sales meeting. But that's a good question because it is required for optimal operation. Now, I suppose a person could not switch the airflow, but if you don't switch the airflow, then what's going to happen is the outdoor unit is not going to give you the full benefit of reduced modulation and reduced capacity and the ultimate comfort. But I can't say I disagree with you on that.
Well,
Good
Joe,
question.
I think there's a couple reasons. First of all, this is a third party vendor that we go through for this product. Okay. So, and the other side of it is depending on if it's a two-stage variable speed product versus just a straight ECM, there's two different kits.
That is true. That's a good point.
So, I mean, and I know where you're going. I know where you're coming from on this. But the companies that have put these in and installed them are just, I mean, and I'll make sure I get you guys some names of some of the companies that have put these in. Their dealers they're loving it. They just absolutely love this unit. So I don't know if it's that big of a deal, Joe, but I see what you mean as well. But again, it is a vendor. It's a third party vendor that we're buying these products from. And as you learn more about this product, Joe, this is an unbelievably versatile piece of equipment.
That's a good point.
So
yeah,
it does a lot of different things.
And to Randy, to your good point right there, of all the products we have in our inventory, this thing will match up with anything we have in our inventory on the indoor product, with the exception of the the AVV air handler and the the Momentum fully communicating system. It'll literally match up with all the furnaces, except the big communicating only one, for the Momentum unit. But basically any of our AE air handlers, variable speed air handlers, single stage, two stage, variable speed furnaces, it'll match with all of it. To your good point.
So is there you said there's a different kit for the variable speed furnace?
There is. It's what we call the 002 kit.
There's two kits.
And so the 002 kit, which we'll talk about in a little bit, is for the variable speed products. It basically just has two relays on the board instead of one relay. And but the 002 kit is really kind of a universal kit because you can use it on anything, but you have to have it on the variable speed. The other thing is too, Joe, if you get pushback from your contractors, or you get some pushback, from the customers about it, there are ways that you can just take like a generic switching relay and put your own bi-flow filter dryer on. But by the time you mess around and assemble all those parts, the kits are very, very convenient. But I mean, there's we could have that conversation if you wanted to build your own kits, we'll say. But
no, I just need to make a note to remember in the system that when someone orders one of these units, they need one of these kits. So I just need to make sure I know which kit they need.
There you go. There you go.
To put the note in so the counter guy knows, hey, make sure you take this kit, because the last thing they want to do is get to the job or get done almost done with the job, and they don't have the kit to start the unit.
Yeah, there you go.
Joe, did you see the attachments I had on the invite?
Yeah, I do now. Yeah.
There's a quick reference sheet in there, and that notes it in there for you.
Perfect.
So just take a look at it, after the meeting. And
absolutely. And fellows, by the way, too, please, everyone on this call, if you run into additional questions or comments or whatever, please call me. If you'd like to write this down right now, my phone number is 251 area code 510-8563. And that's my Johnson Controls company phone that they provide to me. And I answer it most any time. So if I'm on the phone with another customer, just please leave a message and we'll call you back. Okay, good, excellent. Fellas, the next thing we're going to talk about is specifically now, please remember on the AE air handler, actually all of our air handlers, if you do get a W1 call on a AE air handler, what's going to happen is it's going to go to high speed. Now, remember, all of our ECM motors are designed that if they have more than one speed command on them, they'll go ahead and drive to the highest speed command. So during defrost, what this means during defrost, even if you have an S1 call on the relay for reduced airflow, if you get an auxiliary heat call or a defrost call, even if it's in reduced capacity, what's going to happen if you get a W1 call, it's going to drive that fan to high speed, and it will basically be ignoring that S1 signal, that reduced airflow signal, if you get an auxiliary heat call. And please, again, one more time, remember that W1 will be present with the thermostat auxiliary heat call or during the defrost cycle. Okay. So the next subject we're going to talk about some furnaces now. And Randy, up in your neck of the woods, this is probably going to be a little bit more prevalent than air handlers, but we're going to be talking about specifically the TME and the TMY standard ECM motor furnace products. So we're going to get in there. We're going to look at the low voltage wiring like we just did with a simplified block wiring diagram. And please remember the TME furnace is a single stage furnace and the TMY is a two-stage heating furnace. Now the wiring of that accessory single pole double throw kit in the outdoor unit is now going to be used again for airflow reduction. So I won't read all the way through that again. Just remember the 001 is for convenience and supplied parts, and for single stage operation and two-stage operation in this example. And then the 002 kit is going to be for the variable speed product. Now, concerning furnaces, please remember the heat pump thermostat still has to have that BO selection for reversing valve operation. And please select a thermostat with dual fuel function if you're going to be using it with a furnace product. So let me stress that one more time. Make sure that whatever heat pump thermostat that you use has got a dual fuel function, because the dual fuel function will be driven from the thermostat levels. So the outdoor unit, our outdoor unit, and our indoor product, we don't have like dual fuel kits built into them. And so we're depending on the heat pump to switch over heat pump to furnace and so on. So be sure that you select a heat pump thermostat with dual fuel function. And you'll find that most of your better heat pump thermostats have got that dual fuel function in there anyway. They may require an outdoor sensor. They might be Wi-Fi driven to where they know the outdoor temperature by the Wi-Fi. And again, our product, as well as our outdoor product, our indoor and outdoor product, are compatible with all the major brands of heat pump thermostats, as far as, Honeywell, Robert Shaw, etc. So just a standard heat pump thermostat, your favorite heat pump thermostat with BO selection and dual fuel capacity or capability if you hook it up to one of the furnaces, please. Let's go ahead and start out with a TME single stage furnace. And so this does have hard screw terminals on it. So we're basically featuring terminals on the furnace and our outdoor unit. And remember that heat pump thermostat has to have dual fuel capability. So just like before, we're going to energize that B terminal for reversing valve operation in the heating mode. So we'll take B from the thermostat straight outside to B terminal on the outdoor unit. And because this is a single stage furnace, we're only going to utilize the W1 on the heat pump thermostat, and that'll go to W on the single stage furnace, and then that'll carry straight outside to W outside. Because remember, team, whenever we go into defrost, we're going to have to bring the heating system on as well during defrost, because when we switch that heat pump into defrost, it's actually going into the cooling mode to defrost it outside, and we don't want to freeze the homeowner out. So we always need to bring on auxiliary heat or supplementary heat during defrost. Now, just like we had before with our air handlers, that W is our compressor call that goes outside to the outdoor unit from the thermostat. C is 24-volt common, just like we had before. You'll notice it looks a lot like our air handler, and it is. It's just that we have hard screw terminals on the indoor product, and we may have a little different terminal configuration than we had with our air handler, but it's essentially the same type of wiring schematic. Ours 24-volt hot, and please remember, team, that goes strictly from the indoor unit to the heat pump thermostat. It does not go outside. R does not go outside. G is still our 24-volt signal for fan operation. It's like we had before. G is our 24-volt call for fan operation from the thermostat. And we're going to feature that same 001 relay kit. And one side of that 24-volt coil will go to S1, just like we had before. And the other side of that 24-volt coil, we're actually calling it A, will go to 24-volt common, that common wire that goes from the thermostat to the indoor unit to the outdoor unit. So we can energize that relay for reduced airflow. Now watch this, because the terminals are a little bit different. We're going to see that 24-volt common on the switching relay itself is still going to go to Y terminal like we had before, but you're going to notice that your normally closed contact is now going to go over to a terminal on the furnace that says Y/Y2. Now automatically what Y/Y2 is on that's high-speed airflow. So high-speed airflow, cooling airflow, Y/Y2 will be on our normally closed contact on the relay. You'll notice that the normally open contact on the relay will go up to Y1, and that Y1 is our first stage cooling call on our furnace product for first stage cooling. So on our TME furnace, we're going to find that we've actually got hard physical screw terminals, but it's wired very much electrically, just like we had on our previous slide with our air handler. Now, as we go in and we take a look at it, we'll see that this single pole double throw relay, again, is a very, very simple relay with a 24-volt coil, and just hooking it up real simply like we did before. Any questions or comments so far before we start looking at some other features with a two-stage furnace and a couple other things? Any questions or comments?
Joel, I just want to make sure that the guys have a good grasp of this, but you're talking about the relay going, one side of the relay going to Y1, Y2 for high blower speed, and going to Y1 for low blower speed.
That is correct.
Even though it's a single stage furnace.
That is correct. So that's an excellent observation and question, Randy, because our TME, it turns out that our TME single stage furnace has got two-stage cooling capability. Now that's something we really don't talk or advertise much, but that's an excellent observation on your point, because even though it's a single-stage heating furnace, our simple single-stage TME single-stage heating furnace still has two-stage cooling capability. Isn't that neat? And so that is correct. So even though it's a single-stage heating furnace, it does have two-stage cooling capability. Good observation.
The other question, Joel, was when it goes into defrost is the indoor blower going to go to high as well? Because I know the compressor speeds up outside.
Correct.
But does the blower indoor, does that go to high or does that stay on low?
That's an excellent question. As it turns out, the heating airflow is going to be higher typically on these furnaces. The heating airflow is going to be higher than cooling airflow. So it will drive it to the highest airflow that, so let's say, for instance, let's say we have a Y2 call on there because the compressor's running outside. We go into defrost, and then we call for a W call as well. The ECM motor, because all these E type of products, TME, the AE, and so on, those are all ECM type motors. So let's say, for instance, the cooling airflow, the Y airflow, is higher than the heating airflow on this furnace. It'll stay on the cooling airflow. If the heating airflow, when you get a W call, if the heating airflow is higher than the cooling airflow, these ECM type motors, they always take the highest airflow command they're receiving. So even though you might have Y cooling airflow, say 1200 CFM on a 3-ton unit, but maybe the heating airflow on this TME furnace is 1400 CFM. So if it sees a W call, it'll drive it to that 1400 CFM. Does that make sense? So basically, if that ECM motor sees more than one call as far as input for speed input, it'll always take the highest input. So based on the furnace model, and based on the tonnage of the outdoor unit and so on, it'll take, when it sees a W call, if that W is higher than the current airflow call, it'll drive it to that higher call. Good question. Did that answer your question okay?
Yeah. Thanks, Joel.
Okay. There you go. So let me throw a little cog in there. So let me ask you a question back. Let me ask the group a question back. So let's say I had an S1 input and I was on reduced airflow. Let's say it was on Y1 airflow, reduced airflow. And then all of a sudden I get a heating call. Let's say reduced airflow is 800 CFM. And all of a sudden we get a W call, and the W call is 1400 CFM. What's the motor going to do?
It's going to want to jump to the higher, the higher heating.
Yeah, absolutely. So regardless of what S1 is doing, reduced airflow Y1 and Y2 or not, whatever airflow is higher that motor receives, it's going to jump to that airflow. Excellent answer. Any other good questions or comments before we continue?
If we're good.
Okay, team, here we go. So let's take a look at a TMY 2-stage furnace. Now, please note the TMY furnace low voltage wiring and the relay is going to wire exactly like the TME furnace that we just discussed. The only exception is the TME or the TMY is a 2-stage furnace and requires a W2 terminal. And so as we take a look at it, there's a slight terminal change. It wires exactly like we had before. Y1 still goes to normally open. Y2 goes to normally closed. Everything wires exactly the same. B goes to B. However, because the TMY is a 2-stage furnace, a 2-stage heating product, it's also 2-stage cooling, just like you can see on the schematic. But because it's a 2-stage heating product, we're going to take W2 from the thermostat and hook it up to W2 on the furnace. And then W1 from the thermostat will go to that W/W1 terminal and take it outside. So the only difference between the TMY and the TME is the fact that we have another terminal for this 2-stage furnace. Does that make sense to everybody?
Yep.
And so there you go. Basically, both of those furnaces are very, very popular furnaces, and they'll work absolutely perfect with our HMH7 and a dual fuel application. Now, please remember that thermostat has to be dual fuel for it to work properly. Now, team, let's go ahead and look at an animation real quick, and let's energize that S1 output. And we see that S1 output, again, it's going to switch that relay, and it's going to switch from high-speed cooling to low-speed cooling, from Y2 to Y1. If we have a reduction in capacity outside, we'll switch that airflow. But please remember, team, again, because it's a standard ECM motor furnace, both TME and TMY are both standard ECM motor furnaces. We find that if we do have a defrost call and we have a higher speed command, it'll always switch to that highest speed command on that motor that it's receiving. But just like we had before, let's say we're in the cooling mode of operation. So in the summertime, a mild day, we get an S1 output from the outdoor unit. It switches that relay. We reduce that airflow inside to perfectly match, or to more perfectly match, the airflow requirement with the reduced capacity outside. So that's where the real comfort comes in. This outdoor unit's going to modulate down as it starts getting milder outside, or the temperature inside the space starts getting close to set point. It's going to modulate down. It's going to reduce the airflow, keep the unit running a little bit more, provide wonderful humidity control, and just a level of comfort that's unattainable with a single stage product. Any questions or comments before we continue with some variable speed products, air handler and furnace, to be specific here shortly? Any questions or comments?
Joel, just so you know, I have a 2 o'clock. So
Okay.
if it gets to that, I'm going to jump off. You can finish up here, and then I'll have the recording, and I want to pass the recording to the two guys. There's one guy with COVID, and the other guy is having a problem getting on. So
no problem. So if Joe's still on, Joe, if you'd like to go ahead and unmute your mic as we continue the rest of this, you can ask your questions, or you can mute your mic and then unmute it if you do have a question. Because I can't see the chat box. Randy was kind of watching the chat box for me, but Joe and other participants, if you have a question, please unmute your mic and ask those good questions. We'll be glad to answer those for you as we progress towards the end of our program.
So Treg, you can unmute your mic as well if you have any
Absolutely.
questions. So, and then if you guys have any questions following the meeting, we can go through it as well. I'm going to actually be sending you some things. And I want to let you know that this is in the field reference guides, the HMH7, and it's a wonderful read. You guys you'll enjoy it. So thank you, Joel.
Absolutely, Randy. Thank you. Okay, fellas, let's go ahead and take a look at this time. We're going to be discussing a low voltage wiring and setup with a variable speed air handler and a variable speed furnace. Now, it should be noted that the low voltage wiring with the variable speed air handler and furnace, we're going to use a simplified block wiring diagram like we had before, and there will be terminals that are not used for the HMH7 covered. Some examples would be like the Hume terminal. The Hume and dehume terminals on an EAC or the EAC terminals on the air handler or furnace are going to be strictly for indoor use, as far as dehumidification or electronic air cleaner and so on. Now, it should be noted also, please, that the wiring accessory relay kit number 002 will be required for the variable speed product. So this is really important because that kit comes with 2 relays mounted on a board, and they're designated RV and S1 relays. And again, this kit is recommended for convenience and supplied parts. Now, the obvious question one more time comes up, well, gee, a contractor says, well, I got my own Bioflow filter dryer. Can I just take 2 standard single pole double throw relays and make up my own kit? Well, of course they could. It's not a problem. They could do that if they wanted to. However, we provide and we recommend the 002 kit, the HMH7AK 002 kit, if it's going on a variable speed air handler or a variable speed furnace. Now, guys, please remember also the heat pump thermostat has to still have that BO selection on this variable speed product, a BO selection for reversing valve operation. And remember to please select a heat pump thermostat with dual fuel function whenever you use the HMH7 in a dual fuel capacity with a heat pump, or more specifically, a furnace product. So with that said, let's go ahead and walk through. You'll notice on the screen we have 2 relays now. We have one relay designated RV relay, and we have another relay designated S1 relay. So just like we had before, it's going to look very, very similar to you. That B terminal is going to go straight outside to the B terminal outside just like we had before. Now, as it turns out, our variable speed air handler and our variable speed furnaces are both two-stage heating capable products. So we're going to feature a W1 and a W2 as well on both products. So on the variable speed air handler, your W2 is going to go to W2 from the thermostat to the indoor product. W1 will be your first stage heating call or your first stage auxiliary heat call. And that's going to be carried straight outside, kind of like we had before, W1 to W1 to W outside. Y terminal will go outside just like we had before. C is our 24-volt common. And again, this is all looking very familiar to everyone, I'm sure by now, because it's essentially the same wiring that we've had before. It's just that we're featuring two relays on a variable speed product. R terminal is 24-volt hot, and please remember, it's just going from the thermostat to the indoor product. And G is our 24-volt fan call. Now, where it starts getting a little bit different now on the variable speed air handler and the variable speed furnace is we have a couple terminals on there that are going to be a little bit different. The O terminal has to be dealt with on a variable speed product, and we'll talk about that in a minute or two. Let's start out with our two relays. So both relays, one side of both relay coils, we'll call them the A terminals in this example, both relay coil A terminals are going to go to 24-volt common. So that's our common terminal for both relay coils. The B terminal, or the other side of the 24-volt common, or the 24-volt relay on S1 relay goes up to S1. That's kind of why we call it the S1 relay. So that's going to be energizing that relay that we've looked at before. It's essentially the same wiring. On the S1 relay, we're going to take the Y signal to the outdoor unit, from the thermostat to the outdoor unit. We're going to tie it onto the common switching terminals on the S1 relay. The normally closed contact on the S1 relay is going to go over to Y/Y2, very much like we had before for our high-speed airflow. In the cooling mode of operation, that Y/Y2. And then the normally open on the S1 relay is going to go to Y1. So this is very similar to what we've had before with just a single relay. But now remember, on a variable speed product, we've got that RV, that second relay we have to deal with. So the B terminal on the RV relay goes up and ties on to our B. Now what happens is this: anytime we have a call for heating, on the heat pump, thermostat, that B terminal is going to be energized. That B terminal is going to be energized for reversing valve operation on the outdoor unit. At the same time that happens, it's going to energize that RV relay coil you can see in the block diagram. Now, how this works is this: the C terminal on the RV relay, the common terminal for the switching contacts, goes up and ties on to Y, just like we had on the other relay, right? So the compressor's running. We have 24 volts on that C terminal. Now watch this. The normally closed contacts on that RV relay go over to the O terminal on the variable speed product. Now, this is real important. On our variable speed indoor product, it has to see an O signal. It has to see an O signal in the cooling mode of operation for the indoor product to work properly. When you go into the heating mode of operation on the indoor product, we have to break that O signal to tell the indoor board, to tell the indoor logic on the board, the control board, that, hey, I'm in the heating mode. So that's the only reason that RV relay is there, is to make and break that O terminal on the indoor product only, that O terminal in the heating and the cooling mode. Does that make sense to everybody? Any questions or comments on that? Okay, so that's our basic logic right there, is that RV relay. The only reason it's there is to break that O terminal in the heating mode of operation. So as we take a look at this, you'll notice as we kind of jump into our TMV two-stage furnace, It's going to wire exactly like the air handler, except the TMV furnace, we've got the heating terminals are labeled slightly differently. So in other words, instead of having just like a W1, W2, we're going to have a W/W1 and a W2 terminal. But other than that, it wires exactly like the air handler as far as the terminals, the Y1, Y2, O terminal, etc. So that makes it pretty simple for a two-stage variable speed furnace. Any questions or comments before we do some animations for everybody? Everybody good?
So you don't hook up on that RV, you don't hook up the normally open?
That is correct. That's a good observation and question. That's correct. So that normally open is not even going to be used on that RV relay. And what happens is when we'll show you in an animation here in a minute or two, when we go to heating mode of operation with that B terminal energized for the reversing valve, it's going to switch that relay, and it's going to break that O signal to the indoor board. That's the only reason that RV relay is present, is to break that O signal in the heating mode of operation. That is correct. Good observation. Okay, so let's go ahead and just a quick reminder that the TMV furnace does require a dual fuel heat pump thermostat. And then let's go ahead and look at some animations. So we notice that when we switch S1 from the outdoor unit, just like we had before, we're going to switch the S1 relay for low airflow. And so that S1 relay switches and commands low Y1 airflow on the indoor unit, just like we had before. Now watch closely on the animation. What's going to happen, we notice that the RV relay switches with the thermostat B terminal energized, and it opens that O terminal in the heating mode of operation. So as you take a look at that animation again, let me do that again real quick on that RV relay. Watch it closely. Bang, we switch it in the heating mode. When we go to the heating mode on the thermostat and we energize B terminal, it energizes that RV relay and it takes 24 volts off of that O terminal. That's the only reason that RV relay is there, is to take 24 volts off of O terminal on our variable speed products in the heating mode. Any questions or comments on how these relays and stuff are working with our indoor product? Everybody good? All right. Well, fellas, let's go ahead and talk a little bit about some airflow considerations when the contractors are building their ductwork and stuff like that. Please remember on every install to confirm proper airflow. The HMH7 is a modulating capacity unit, and nominal airflow is critical. Now, we want to make sure they size their ductwork to 400 CFM per ton of total capacity. This is important. We want to make sure that they're providing the proper airflow, because what's going to happen, because it's a modulating system, if it sees reduced airflow, or if it sees the coil inside starting to ice up or freeze up or whatever, it's going to screw back on the capacity. So airflow is really critical on any modulating system. It doesn't matter whose brand it is. If you don't have the proper airflow, the modulating system is not going to be able to sense what capacity it should be at if it has inadequate airflow. So it's important that we stress to our customers to double check that airflow and make sure the ductwork is sized to provide 400 CFM per ton of total capacity. Now, some airflow considerations as far as velocities are concerned. This is right out of ACA Manual D, and if you've had opportunity to look at Manual D, it's kind of the Bible, if you will, for airflow, for residential airflow considerations. And so if you look at that airflow velocity table, this is right out of Manual D. We see that our main trunk velocities, recommended velocities are around 700 for the main trunk, maximum 900, and so on. And returns, you can kind of look at that chart right here. Branch ducts, they specifically address branch ducts at about 600 feet per minute is recommended on supply, and about 400 for return. Registers and grills, 500 feet a minute on the supply, 400 on return. Diffusers are about the same. And this is a big one. This is really, really important. If the homeowner or if the contractor has installed the equipment with a filter grill, so you've got a return grill with a filter in it, it's recommended that they do not exceed 300 feet a minute velocity across that filter, because if they do, it can cause, evaporator issues as far as not being able to absorb the heat properly and stuff like that. So all this again is right in Manual D, and it's also part of our airflow and duct design class, which we'd be more than happy to conduct with everyone on this call at some future date. Any questions or comments as we start to kind of wind down our HMH7 heat pump overview today? I'd like to go ahead and open the floor up a little bit for any final questions or comments. And as a matter of fact, I think what I'll do is I'll go ahead and turn my camera back on, and we'll jump out of the presentation at this point. And so let me get my camera back on and show my smiley face. Is there any final questions or comments that we could present to everyone, or we could talk to anyone about? Let's go ahead and open the floor up for a minute or two.
So you call it a modulating unit?
Yes.
Does it? But then you also shared that it was 5 stages.
Yeah, and I actually misspoke on that. I was thinking about our TH16 product. Our TH16 product is actually 5 distinct steps, but this new HMH7 on reflection actually modulates from 35 to 100% capacity. And so I actually misspoke on that. I apologize.
No, that's okay. I just want. So does that modulate in 1% increments, 2%?
I'm not real sure. I think, that it's kind of proprietary. There's certain things that it's a third party item. There's certain things that they haven't really told us as far as their control scheme and whatnot. But we do know the range is 35 to 100%. And I believe it has the capability of 2 things. It has the capability, you can actually, there's a function you can go in on the control board, and you can reduce the capacity like a 1/2 ton. So if you have a 3-ton unit, you can really tell it, hey, we're really a 2.5 ton capacity. So you can reduce capacity on it. And there's also an internal feature. I believe it will overdrive under certain conditions for a short period of time, maybe like 5 minutes, up to like 105% capacity. So it kind of like a little overcool situation. So it's very, 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 very intelligent unit. That has a lot of good features as far as humidity control and comfort and all that stuff. But the big thing is we let the outdoor unit, via that relay we were talking about, we let the outdoor unit make intelligent decisions on when we're going to reduce that airflow to that 60 to 65% capacity. So a good question you're probably thinking about right now is, well, if I'm at 40% capacity, what's my airflow? It'll be that 60 to 65% to better match the capacity of the outdoor unit.
So if it does get down to 35, 40%, well, can it sense if the coil's starting to ice up?
Well, that's a good question. So if the outdoor unit's at 30 or 35 or 40%, and we're blowing 60% airflow on that, it'll generate that S1 call. And the indoor unit's actually blowing 60% airflow, so it shouldn't ice up if we have 60% airflow inside and 40% capacity outside, if that makes sense.
Right. But it could ice up if it was reversed, 60
yeah, so
75% capacity and 60% airflow.
Yeah, see, I like the way you think. So that's exactly why, we have a liquid line sensor, suction line sensor, suction pressure transducer. I think it also has a liquid pressure transducer, outdoor air temperature sensor. So between all of those sensors, the unit's going to sit here and it's going to see that, hey, I need 75% capacity, but I'm currently generating an S1 call. So I'm going to stop that S1 call. I'm going to allow the indoor unit now to go to 100% capacity, even though I'm at 75 or 80% capacity outside. We're going to go ahead and bring the airflow back up. So at some point, the unit makes intelligent decisions on when it's going to command low airflow, 60, 65%, or when it's going to uncommand it, if you will, and kill that S1 output. and allow the fan to come back up to 100% airflow for its other points of modulation.
So
that's all that's done from the outdoor unit, again, by looking at outdoor air temperature, liquid line temperature, suction line temperature, and so on. The outdoor unit makes intelligent decisions on, do I want reduced airflow or not?
So is there only 2 airflow stages then on a standard ECM furnace?
That's a really, really good question. So the answer is yes. And so on our 2-stage products and on our TME furnace, even though it's a single stage heat, first stage airflow, what's going to happen when you get like a Y1 call, the contractor is going to select a speed tap on that standard ECM motor that's going to approximate 60 to 65% airflow. Now, somebody said to me one time, well, Joel, what if we had 55% airflow instead of 60? Would that still work? And well, of course it would. So the contractor is going to select a speed tap that approximates that 60 to 65% airflow on a Y1 call. And then he's going to select a speed tap that's going to give you 100% airflow on a Y2 call. Now, shift for just a second to variable speed. On the variable speed products, when you set up your airflow jumpers, which you're really setting up on your cooling airflow on a variable speed product, you're actually setting up on the jumpers your 100% cooling airflow. Then the board is smart enough to know that if it sees a Y1 call only, it'll then just take 65% of your jumper settings for 100% cooling airflow, and it'll reduce the airflow automatically from a board function, if that makes sense. So the contractor doesn't have to sit here and select a speed tap on a variable speed product. He just sets some jumpers up for 100% cooling airflow, and then the board, if it sees a Y1 call, it just takes 65% of that electronically and automatically knows and drives the fan to 65%.
Perfect.
Good questions. Any other good questions before we conclude for today?
I'm all questioned out.
Well, I'll tell you what, thank you so much for training with me today. I look forward to it. And again, what we'll do is we'll make sure and get this recording out on our YouTube channel here before the day's out, probably maybe first thing in the morning. And we're going to call it HMH7 heat pump overview, and today's date 01/12/2022. And then you can go out there on that YouTube channel. Randy will make sure you have that link, and you can go out on that YouTube channel with this date code, and you'll know that it was our session today because it has that date code on there. So by all means, go out there and listen to it as much as you like. And there's other videos out there. By all means, enjoy those as well, because you'll have a direct link to my training channel out there on YouTube. And if there's no further questions, Joe, we'll go ahead and call it a day.
Thank you.
Thank you. Have a good day.
Yeah, you too. Thanks.
Bye.